everyone! These are the volume of cylinder, cones, and spheres guided notes. To get started, we're going to review some vocabulary. Radius is the distance from the center of a circle to the edge of the circle. Diameter is the distance from a point on a circle through the center to another point on the circle. Circumference is the distance around a circle. Area is the number of square units inside a space. Practice. Calculate the circumference and area of the circles. So a quick review of the formulas for area and circumference. Circumference of a circle is 2 times pi times the radius, or pi times the diameter, and the area of a circle is pi times the radius squared. The circumference of this first circle with the radius of 3 meters. The circumference would be 2 times pi times the radius, which equals 6 pi, which is about 18.8 meters. The area is pi times the radius squared, or pi times 3 squared, which equals 9 pi, which is about 28.3 meters squared. The circumference of this circle has a diameter of 0.2 centimeters. The circumference is the diameter times pi, or 0.2 pi, which is about 0.6 centimeters. To determine the area of the second circle, we need to first determine the radius. We know that the diameter equals 0.2 centimeters. The radius is going to be half of that, so the radius will be 0.1 centimeters. My area is going to be the radius, 0.1 squared times pi, which equals 0.01 pi, which is about 0.03 centimeters squared. The radius of a circle is 2.5 feet. The circumference would be 2.5 times 2 times pi. So that would be 5 pi, which is about 15.7 feet. The area would be 2.5 squared times pi, which is 6.25 pi, which is about 19.6 feet squared. Now we're going to review how to calculate the volume of prisms. Recall that a prism is a solid figure with two identical parallel bases and flat faces. To find the volume of any prism, you multiply the area of the base by the height or the distance between the two bases. The base shape is the shape that has a parallel and congruent face. Identify the base shape of the following prisms. If we are looking at this shape right here, this actually is unique because it has a couple of different bases that we could use. This face and this face are both parallel and congruent. This face and this face are both parallel and congruent. The top and the bottom faces are also both parallel and congruent. So this one is unique because it has different faces, but they are all the same shape. So the shape of the faces is a rectangle. If we're looking at this shape here in the middle, the two faces that are both parallel and congruent are these triangles. And lastly, this shape right here, the two parallel and congruent faces are these shapes right here, and those are hexagons. A cylinder is similar to a prism with the base shape of a circle, because a cylinder has two parallel circles that are faces. Therefore, the volume of a cylinder using the formula V equals capital BH, so that B represents the area of the base, is V equals the area of a circle is pi r squared. That's where this comes in right there, capital B, the area of the circle, and times h, which is the distance between them. Because the area of the circle is pi r squared, and that represents capital B in the formula. The volume of a cylinder is V equals pi r squared h. Find the volume of the given cylinder. The area of the base will be pi times my radius, which is 8 squared, which equals 64 pi, and we'll just leave it in exact form right now. so 64 pi meters squared. The height or distance between the bases, which is the distance right here, that's the distance between my bases, and that is 20. The formula for the volume of a cylinder is V equals pi r squared h. The volume of the cylinder is, I'm going to multiply my area of my base, which is 64 pi, times 20. That gives me 1,280 pi, which is 4,021.2 meters cubed. That's the volume of this cylinder. The pipe shown here has a diameter of 2 feet and a length of 12 feet. If it's giving me dimensions, I like to label my picture if I can. So the length is 12 feet and the diameter is 2 feet. The area of the base. So the base are these circles right here because they are parallel to each other. For the base, I need to know my radius. My diameter equals 2, so my radius equals 1. The area of the base is going to be pi times the radius squared, which equals pi times 1 squared, which equals pi times 1, which equals pi. The height or distance between the bases is 12. The volume of the pipe, so I will multiply the area of the base, which is pi, times the distance between them, so that gives me 12 pi, which is approximately 37.7 feet cubed. A can of soup has a base area of about 4.9 inches squared. So the soup base is going to be a circle. It's telling me the area. I don't need to figure that out. The volume of the soup can is about 18.62 inches cubed. How could you determine the height of the soup can? The formula for the volume is V equals large B is going to be the area of the base. So V equals large BH. If I divide both sides by the area of the base, or the area of the circle in this case, I can determine the height by that. So volume divided by the area of the base. In this case, the volume was 18.62, and I'm going to divide that by 4.9, and that gives me about 3.8 inches. Calculate the volume of the cylinders below. Volume is going to equal my area of my base, which is this circle down here at the bottom. So that's going to be pi times my radius squared, so pi times 2 squared, and I will multiply that by the distance between the bases, which is 1.5. If I multiply all of that together, I get 6 pi exact form, and that is about 18.8 centimeters cubed. Looking at the cylinder here in the middle, I notice that it tells me my diameter, but does not tell me my radius. My radius will be half of my diameter. My radius will be 0.5. So the volume is going to be pi times my radius, 0.5 squared, multiplied by the distance here between them, which is 3. So when I multiply all of that together, I equal 0.75 pi. That's my exact form. My approximate form is 2.4 feet cubed. A cylinder has a base area of about 15.3 meters squared and a height of 3 meters. So if I want to figure out the volume is going to be the area of the base, which is 15.3 times 3, and that is about 45.9 meters cubed. How are a cylinder and a cone similar? They both have a circled base. How are a cylinder and a cone different? Cylinder has 2 bases and a cone just has 1 base with the apex. Let's say a cone and a cylinder have the same size of base and are the same height as in the photos below. Would the cone or the cylinder hold a larger amount of water? So we look at these two shapes. They both have the same height, the same diameter of the circle. The cylinder is going to hold more water because the sides of the cone slope to a common vertex, therefore decreasing the volume. If a cone and the cylinder have the same size base and the same height, the volume of the cone is 1/3 the volume of the cylinder. So if the volume of a cylinder is pi r squared times h, the volume of the cone is going to be 1/3 of that, so divided by 3. Or I can also write that as 1/3 times the volume of the cylinder, pi r squared h. So dividing by 3 or multiplying by 1/3 will give me the same answer. The volume of a cone V equals pi r squared h, the volume of the cylinder, divided by 3. Find the volume of the given cone. The area of the base, here's my base right here, it gives me the radius of 8, so my area of the base is going to be 8 squared pi, which equals 64 pi. The height is 20. I can see that right here, 20. The formula for the volume of a cone is pi r squared h divided by 3 because it's 1/3 that of the cylinder. The volume of the cone is 64 pi, the area of the base, times the distance between them, 20, and I'm going to take that and divide that by 3, and that equals about 1,340.4 meters cubed. The cone shown here has a base diameter of 3 centimeters. Again, I like to label if I can. So the base diameter is 3 centimeters and a length right here of 9. The area of the base, well, it tells me the diameter, d, equals 3, but I need to know the radius. So the radius will be half of that, 1.5. So the area of the base is going to be 1.5 squared times pi, which will equal 2.25 pi centimeters squared. The height is right here, that's going to be 9. So the volume is going to be the base area, which is 2.25 pi, times the height divided by 3. And that is about 21.2 centimeters cubed. A cone has a base area of about 4.9 inches squared. The volume of the cone is about 18.62 inches cubed. How could you determine the height of the cone? This question is kind of similar to the question on the previous page. The formula for the volume of a cone is, we can also write capital B for that area of the base, which is a circle, but capital B times h divided by 3. Now, if we want to solve for h, we're first going to multiply each side by 3. So that's going to be 3 times the volume equals BH, and then we're going to divide each side by B, so that's going to give me H equals 3 times the volume divided by the area of the base. Now it asks us to determine the height of the cone. So we will do 3 times the volume, which was 18.62, divided by the area of the base, which is 4.9, and that is about 11.4 inches. Practice. Calculate the volume of the cones below. We're looking at this first cone right here. We need to know the area of the base, which is pi times the radius squared, pi times 2 squared, times the height right here, which is 7, and we're going to divide that by 3 because it's a cone. That gives me an exact answer of 9.3 pi, which is approximately 29.3 centimeters cubed. Looking at this cone here in the middle, I notice that it gives me the length of the diameter, so the radius will be 3. My formula, pi times my radius 3 squared times the height, which is 5, divided by 3. That gives me an exact answer of 15 pi, which is an approximately 47.1 feet squared. A cone has a base area of about 15.3 meters squared and a height of 3 meters. So my volume is going to be the base area 15.3 times my height of 3, all divided by 3. Well, those will actually cancel out. So the volume is going to be about 15.3 meters cubed. Now let's talk about spheres. To determine the volume of a sphere, let's first compare a cone and a hemisphere. A hemisphere is half of a sphere. This is a hemisphere right here, half of a sphere. Let's say a cone and a hemisphere have the same size base and are the same height as in the diagram below. Which one do you think would hold more water? Well, that's your opinion, so you can write what you think here. If a cone and a hemisphere have the same size base and are the same height, the volumes will actually be equal. Therefore, the volume of a hemisphere is the same as the volume of a cone. Pi times the radius squared times the height, all divided by 3. Since a sphere is 2 hemispheres, the volume of a sphere is double the volume of a hemisphere. So that's going to be 2 times the volume of a cone. Now, the height of a sphere is the same as the diameter. So you can replace the height in the equation, h, with the diameter. And in terms of the radius, that would be 2r, because the diameter is 2 times the radius. So we're going to rewrite this formula in terms of the radius. So if I have 2 times pi r squared h divided by 3, instead of h, I'm going to write 2 times the radius. So 2 times pi r squared times 2r, which is the diameter, divided by 3. On the top, to simplify, I have 2 times 2, which is 4 pi, and then I can combine these radius here. So I have radius squared and radius, which is going to give me radius cubed, and then still divided by 3. So you have just derived the formula for the volume of a sphere, which is 4 pi r cubed divided by 3. Find the volume of the given spheres. The length of the radius is 5. The formula for the volume of the sphere is 4 pi r cubed divided by 3. The volume of this sphere is, so let's figure that out. So 4 times pi times the radius, which is 5 cubed, all divided by 3. If I calculate that out, the exact answer is 166.6 repeated, pi times pi. The approximate answer is 523.6 meters cubed. The sphere shown here has a diameter of 2 feet. Let's make sure to label that. So the radius is going to be 1 foot. The volume of the sphere, volume equals 4 times pi times the radius cubed, so 1 cubed divided by 3. That will give me 1.3 pi, which is about 4.2 feet cubed. Professional basketball players use a basketball with a circumference of 29.5 inches. How could you use this information to determine the volume? Well, if I know the circumference, I can determine the radius of the ball. So if I can determine the radius of the ball, then I can use that information to determine the volume. The radius of the basketball is, I know the circumference is 29.5, and that equals 2 times pi times r. So if I take 29.5 and I divide it by 2 pi, that's going to give me the radius. So 29.5 divided by 2 pi, the radius is equal to 4.7 inches. I can now calculate the volume by using the formula for the volume of a sphere, which is 4 times pi times my radius, which is 4.7 cubed, divide that by 3, and that is about 434.4 inches cubed. Calculate the volume of the spheres below. In this first sphere, it gives me the diameter. I know in my formula I need to know the radius. So the radius will be 4. The volume equals 4 times pi times my radius, which is 4 cubed. Take that and divide that by 3. I just plug this into my calculator. My exact answer is going to be 85.3 repeated pi, which is approximately 268.1 meters cubed. The sphere in the middle, it gives me my radius, plugging it into the formula V equals 4 times pi times 1.5 cubed divided by 3. That is exactly equal to 4.5 pi, which is approximately 14.1 feet cubed. And I'm just plugging these numbers into my calculator. A ball has a volume of 268.1 centimeters cubed. Determine the radius. Let's start by substituting in what we know. And here's my formula right here that I wrote down in case you need to refer to it. My volume is 268.1, and that equals 4 times pi times my radius cubed divided by 3. To start, I'm going to multiply each side by 3, and then I'm going to divide each side by 4 pi. So I know that my radius cubed equals 3 times 268.1 divided by 4 pi. To figure out the radius, I'm going to take the cube root of each side, and I'm just going to plug all this into my calculator, and that tells me that the radius, r, equals 4 centimeters. Determine which size of cup cone will hold the least amount of ice cream. Determine which size of cup or cone will hold the most amount of ice cream. Explain your reasoning. If I want to determine like the space inside, that's going to be volume. So my thinking is I will determine the volume of each of these shapes, and then we can compare them. So the volume of a cylinder is going to be pi times the radius squared times the height. So the volume is going to be pi times 2 squared times 3. And if I plug that into my calculator, that's going to be about 37.7 inches cubed. Let's do the cone next. The volume of the cone is V equals pi times my radius, which is 1.5 squared, times my height divided by 3. I plug all of that into my calculator, and I get 35.5 inches cubed. This is a hemisphere, not a sphere, but the formula for the volume of a sphere is 4 times pi times the radius cubed divided by 3. Now, since it's a hemisphere, I'm going to also divide that by 2. If I reduce this, 4 divided by 2, that gives me 2. So the formula for the volume of the hemisphere is going to be 2 pi r cubed divided by 3. Substituting my numbers into that, it's going to be 2 times pi times 3 cubed divided by 3, and that is approximately 56.5 inches cubed. So the one that holds the least amount is the cone, and the one that holds the most is the hemisphere. Explain your reasons. I calculated the volume of all the figures above. Okay, everybody, that's it for today. Thank you.